Good evening, everyone. In the previous session, we discussed about Docker file and how to write the Docker file, keywords of the Docker file we discussed. So Docker file contains the instructions to build Docker image. So what steps that we need to give to the Docker software to build our application as a Docker image? Those instructions we are going to write inside the Docker file. In the Docker file, we are going to use the DSL, that nothing but domain specific language keywords. Docker engine will process Docker file instructions from top to bottom. Docker engine will process Docker file instructions from top to bottom. So below are the some keywords we have seen: from keyword, maintainer, copy, add, run, CMD, entry point, env, label, user, work dir, expose, volume. Like that, there are several keywords available, and we discussed what is the purpose of those keywords also. And yesterday, I have taken one Spring Boot application and we have Dockerized that Spring Boot application. So to Dockerize that Spring Boot application, we have written a Docker file. So here we used from directory. Here we are specifying Java. From keyword we are using and we are specifying Java. So what is the purpose of this from? From is used to specify the base image for our application. From is used to specify the base image for our application. Then after I'm specifying copy. Copy command is used to copy the data from our host machine to this Docker image. So in my host machine means in which machine the Docker software is running, that is called as host machine. In the host machine, my Spring Boot application is available. So I'm packaging that application. So it will generate a jar file. That jar file I want to copy into Docker image in this location. And then work dir. So from which directory you want to perform your operations, those things we are going to, that location we are going to specify by using work dir. And one more thing is run command. Run command is used to execute the instructions while creating the image. Here I have given a touch jar file with -c, but basically this option is not required here because already the jar is created by our Maven package goal. So that jar we are copying from host machine to Docker image. So once this jar is copied, I'm going to that location by using work directory. From that work directory, I want to run that jar file. To run that jar file, I'm using entry point. So run is used to execute the instructions when the image is creating. CMD and entry points are used to execute the instructions while creating the container. CMD instructions we can override when the container is getting created by using run arguments, whereas entry point instructions we cannot override. So by using this entry point, I am telling to execute this command. So Java space -jar space this jar file. This is the jar file which I am copying to user/app location. I'm going to that working directory and I'm asking to execute this entry point. So which is going to run my jar file in that application. So that is what we have done in the last session. We have Dockerized our Spring Boot application. So similarly, how to Dockerize one normal Spring application. This is the Spring Boot. How to Dockerize a normal Java web application. Dockerizing normal Java web application. Dockerizing Java web application. Okay. So in order to Dockerize any web application, in order to Dockerize any application, we need to have a Docker file. Let's go to GitHub repository. Go to our repositories. So here, yesterday we worked with Spring Boot Docker application. And here I have taken one application called Java Web Docker app. It also developed by using Spring. It is developed by using Spring, not with the Spring Boot. What is the difference between the Spring and Spring Boot? When you go for Spring Boot, it will give the server by default. Embedded server will be available by default, but when you go for Spring, you need to deploy your application to the server. So for that, I have taken a Docker file. So here I'm just specifying here. I'm just specifying here from Tomcat. I want then directly copy the jar file to Tomcat server. So you see the difference. The yesterday's application is also a Java application. Today application is also Java application. We are Dockerizing. But what is the difference? In yesterday's application, we are telling that go to this location and execute this jar file. But today, what we are doing here, we are specifying from base image as a Tomcat. So yesterday we specified base image as a Java. Tomcat is not required for the Spring Boot. Tomcat will be inbuilt in the Spring Boot. So that's the reason I'm taking a jar file of the Spring Boot. I'm directly executing that jar file. But today application is a just normal Java application. It is not Spring Boot. So server will not be available for the normal Java application by default. We need to install the Tomcat server by using Docker. And in that Tomcat server, we need to deploy our war file. Okay. Are you able to understand these two instructions I'm writing in the Docker file? Are you able to understand the two instructions I'm having in the Docker file? First one is from instruction. What is the meaning of a from instruction? I'm telling this is my base image. This is my base image. This is my base image. I want Tomcat to run my Java web application. My Java web application will be packaged as a war file. I just want to copy the war file from target folder to this Tomcat location. That's it. Okay. So here that project is available. Let's start our EC2 instance. Instance state start. My Docker server is getting started. Let's connect to this Docker server. Let's clone our GitHub application. Then do the package of that application. Once the package is created, then it will create a war file. So then execute our Docker, build a Docker image by using this Docker file. Then with that image, run the Docker container. That container is going to set up our application. We can access our application from that container. Right. Docker server started. Let's take the public IP. Go to this SSH EC2-user, advanced settings, private key, Linux PEM file, open. All right. Let us see Docker info. Docker info false. So what is the meaning of this Docker info false? Docker is running, Docker is not running. Docker is running and Docker is not running. Docker is not running. So how to run the Docker? Sudo service Docker start. I'm running my Docker. Clear. Docker images. So there is one image called Java. Another image is SB REST. So can you tell me how to remove the images? How to remove the images, guys? Docker RMI. Docker RMI image ID. Docker RMI image ID. Docker RMI image ID. Yes, those images are removed. Let us see Docker images. Currently, no images are available. Can we see the containers which are running? Docker PS. Is there any container running in my machine? Container is also not running in my machine. ls-l, ls-l. So we have one default Docker file and one Spring Boot application. Let me delete them also. -r sb app. I have deleted that. rm of docker file. Yeah, ls-l rm docker file ls-l. Okay. Next one, how to remove non-empty directory. How to remove non-empty directory? rm-r sb app remove regular file dot get remove write protected regular file. Okay. Yes. Now that is also deleted. Fine. So can we check that in our machine? Do we have Git version? Do we have Git software? Yes. Do we have Maven software? Yes. Git available. Maven is also available. Do we have Java version? Yes. So we have Git, we have Maven, we have Java. So can I clone my application, Java web application from GitHub repository? Let's go here, Java web Docker app, copy this. By using which command we need to clone this project? By using git clone repository URL, I'm cloning my application. Now cd space Java web app ls-l ls-l. You can see project is available, Docker file is available, pom.xml, src. Do we have a target folder? We don't have a target folder. Can you guys tell me how can I package my Maven application? Can you guys tell me how can I package my Maven application? mvn clean package. Maven is also installed, Java is installed, so mvn clean package. So it is going to create a war file for our Java web application. In which location war will be created? In the target folder, our war file will be created. Now, so once the war is created, we will build a Docker image. So to build the Docker image, we are using a Docker file. In this Docker file, we are having only two instructions. One is from, second one is copy. From is specifying what is the base image to create our image. Copy is specifying to copy the war file from the target folder to Docker image. That's it. Build is happening. Build success. Finally, clear. ls-l. Can you see target folder created? ls-l target. Can you see the war file is created? Can you see the war file is created in the target? Java web app -1.0 .war file got created. Let me cat Docker file. Sorry. Let me cat the Docker file. Cat Docker file. Okay. How many instructions are available here, guys, in the Docker file? From is available, copy is available. That's it. From is available and copy is available in this file. Nothing else. Now, I want to build Docker image. Currently, what are the images available? No images are available. We are having Docker file. I'm in the project directory currently. In the project directory, Docker file is available. Docker files also will be committed to repository. When we learn Jenkins, we discussed about the Jenkins file, right? So Jenkins stages, Jenkins pipeline configuration we will do in the Jenkins file, and Dockerizing of the application, Docker configurations we are going to do in the Docker file. Now, so let me build a image, Docker build -t. -t represents a name for that image. So we can give any name. I'm giving as Java web. I'm giving Java web. Docker build -t Java web dot. So it is going to download Tomcat image first. It is going to download the Tomcat image. Then it will copy my war file to that Tomcat. because Java web application will be deployed by using war file. Guys, if the Java application developed by using Spring Boot is a special concept in the Java. For that Spring Boot application, war file is not required. Spring Boot application will be executed only from the jar file directly. But normal Java applications, if it is not developed by using Spring Boot, then war file will be available. My image is created successfully. So let us see Docker images. So how many images are there? I created one image, but how many images it is displaying? It is displaying two images here. It is displaying two images here. One is our image, another one is the base image. So in order to create our image, we are using a Tomcat image because the Tomcat server we need to deploy our war file, and Java web image got created. So once this image got created, can you tell me the command to run the Docker image? Guys, can you tell me the command to run the Docker image? My image is available. Can you tell me the command? Full command I want. Full command I want to run the Docker image. I want to start a container. I want to start a container. Can you tell me the full command to run this image as a Docker container? Yes. Docker run -d -p 8080. We are using Tomcat. Tomcat will be running on the default port 8080. That is container port. Container port I need to map to host machine port. Container port I need to map to host machine port. I am mapping. Docker run -d. -d means detached mode. What is the meaning of this -d? Without giving -d also you can run this. Without using -d, if you run it, you can't execute another command here. If you use -d, your terminal will be open to execute further commands. So that is called detached mode. This command will execute. After this command execution, container will start. After container started, you can execute further commands in the same terminal. If you give -d, if you don't give -d, then you can't execute the commands. So that is the reason I'm running in the detached mode. Right. Docker run -d space -p. So this is my host machine port. This is my container port. Application will be running on the port number 8080. I am mapping that to the host port. Yesterday I explained you why to map it. And what is our image name? Java_web. Yes, I have started Docker container. It taken care of everything which is required to execute my project. So let us go for Docker PS. Let us go for a Docker PS. Can you see one container started? Port number mapping also it is displaying. So Docker container started. To see the Docker containers which are running, we can go for a Docker PS. All the containers which are executing, it is displaying. Okay, now let's go to public IP of our application. EC2 instance public IP. Application running on the 8080 port. It is also mapped to 8080. Go to 8080 port. Go to 8080 port. Let's give this Tomcat. Why Tomcat is coming? 8080. Tomcat server is accessible. Let me map it to another port number 9090. I think in my host machine Tomcat is running, that is opening. So Docker run -d -p 9090. I am mapping. I have started another container with 9090 port. Let me go to security group, enable 9090 port. I'm running a second container with a different port. Add the rule for 9090 anywhere. Save it. Let's go for 9090. 090 also server is accessible. What is the code available? Let me check it, guys. What is the URL pattern I have for the controller? Welcome controller request mapping slash available slash hello slash name. EC2 instance. Copy the public IP. Colon 9090 slash hello slash name. No. Yeah, Tomcat is not available. Docker PS. Two containers are running. One container is running with the port number 9090. Another container running with the port number 8080. Take the public IP or DNS, anything. DNS with 8080. Our application should open. It is opening Tomcat homepage. If I go with 9090 port, it's opening Tomcat. Dockerizing this application, Tomcat server we are using to run our application. Okay, got it, guys. So for normal web applications, it will use context path. War file name will be used as a context path. Yes. Are we able to access our application now? I was under the impression of Spring Boot. For Spring Boot applications by default, context path will not be available. So this is the problem. As a developer, if we do the DevOps. So for Spring Boot, we will develop the applications by using Spring Boot. Spring Boot applications will not have a context path. Normal web applications will have a context path. So what would be the context path by default? With which name your war file will be deployed to the server? That war file name will be used as a context path. If you see our Docker file, what is available in the Docker file? Vi Docker file. So what is the war file name I am copying to Tomcat server? What is the war file name I am copying to the Tomcat server? Java-web-app. So the project will be accessible with this name only. So see here, I am giving public IP. Public IP I'm going to give. In this public IP, I'm going to specify port number. On which port number our application is running? 8080 and 9090. Two containers are available. Slash application name. What is the application name? Whatever the war file you keep in the server, war file name will be called as your application context path. Now hit this Java. What is the application name I have given? Java hyphen, not underscore. Java hyphen web hyphen application. Java hyphen web hyphen application. So this is one website kind of thing. Hello Docker. This project is developed by using Maven, Spring MVC, and Docker. So this is kind of a project that we have deployed into Tomcat server by using Docker. So the Docker file is very simple. There is nothing available in the Docker file. In the Docker file, just two instructions are available. One is base image that we need Tomcat, and another one is copy. I want to copy the war file from target location to Tomcat server web apps directory. Whatever the war file name you deploy in the web apps directory, that war file name will be called as your project context path. So when you are accessing that application, you need to specify your machine IP and on which port number it is running, 8080, that is mapped to host port 8080 only. This is the port number of the host machine, not the container. Container port is mapped to host port, and this is application context path. Now, so I am running two containers, one container running with 8080, another container running with 9090. In both containers, my application is running. See here, with 8080 also I am able to access, with 9090 also I'm able to access. Why we are able to access with the two port numbers? Because our Docker is running two containers, container one and container one, container two. One container, both containers are running on 8080 only. One container mapped to 8080 port in the host machine, another container mapped to 9090 port in the host machine. So with 8080 port URL, we are able to access our application. With 9090 port URL, we are able to access our application. That means two containers are running. Our application is running in the two containers. Our applications are running in the two containers. 9090 is the host machine port number where our Docker is running. In that machine, I have enabled 9090 port. Docker port number is 8080. Docker is running on the 8080. Tomcat server running on 8080. 8080 port I map to 8080 first for first container, 8080 I map to 9090 for second container. So Docker port is 8080. Our EC2 machine opened 8080. I mapped that container port number to operating system port number, our machine port number. Are you guys clear with this one? After deploying, after running the container, access application using below URL. So what would be the URL? http:// public IP your 8080 / java-web-app. So for Spring Boot applications, context name will not be available, whereas for normal Java applications, context will be available. Okay, cool guys, fine. Are you able to understand how to Dockerize one Spring Boot application and how to Dockerize one normal Java application? Are you clear with this concept? How to Dockerize one Spring Boot application? For Spring Boot applications, we are going to get the jar file. So jar file we are going to run by using Java command. So for that I used Java as a base image. So there is no concept of a war file when you go for Spring Boot application. When you go for normal Java web applications, war file will be available. That war file we need to deploy to Tomcat server. For that I am using base image as a Tomcat. So once that application is deployed, context path will be available. War file name will be called as a context path. That context path name we are going to take it. Okay, cool. Next one, Dockerizing Python Flask application. How to Dockerizing Python Flask application. So Flask is one framework which is used to develop the REST APIs in the Python. How we are developing the Java web applications. Similarly, Python programmers can develop the web application by using Python. So if the Python application is available, then how to Dockerize that Python? So we have seen Dockerizing the jar. So nowadays Java applications are getting developed by using Spring Boot, guys. So if the application is developed by using Spring Boot, you just need to copy the jar file and you need to execute the jar file. If the Java application is not developed by using Spring Boot, then it will be available as a war file. War file you just need to copy to the Tomcat server and you need to access the application by using context path. For Spring Boot applications, by default, context path will not be available. Very good. Next one, Dockerizing Python Flask application. How to Dockerize Python Flask? So let me go to the GitHub repository where the Python code is available. Go to my repositories. Yeah, here Python Flask Docker application. So we don't need to bother about what is the code available for the Python, because developers are going to write the code. Developers are going to push that code into repository. As a DevOps engineer, what is our focus? As a DevOps engineer, what is our focus? Do we need to develop the Python code, or we just need to deploy that code? As a DevOps engineer, we need to develop the Python code, or we need to just deploy that Python application? Come on, guys. We need to develop the Python code, or we just need to deploy this application by writing a Docker file? We just need to deploy the application by writing a Docker file. Okay, guys, in the Python, what softwares that we need to install, they will specify in the requirements.txt. So that is the concept in the Python. There is a file called requirements.txt. In that file, they specified a Flask. That means they need a Flask to run this application. Okay, app.py. This is the actual REST API that they created in the Python. How the Java developers will create the REST APIs by using Spring Boot. Similarly, Python people also will create the REST API. Okay, app.py, app.service.py, dot Java applications will have .java, Python applications will have .py. .py, sorry, it is a Python program. It is a Python program. It is a requirement file. What is required to run this Python application? Okay, it is a REST API which is developed by using Python. So I don't know how to install the Python. I don't know which server is required to run the Python. I don't know what is Flask because I am a DevOps engineer. Python development team is available. Those developers developed Python application. They pushed that code into GitHub. Now, as a DevOps engineer, we need to run this Python application by using Docker. So in order to run this Python application using Docker, we are creating a Docker file. So Dockerizing Python Flask application. Dockerizing Python Flask application. See, here I'm using from Python 3.7. In order to run this Python application, I need Python 3.7 version. So I need to create my image by using base image. For Java applications, I specified. For Spring Boot application, I specified base image as a Java. For normal Java application, I specified base image as a Tomcat. For Python applications, we are specifying base image as a Python. Okay, work directory. Let's go to /opt/app. Copy dot. First dot represents a source directory. Second dot represents a destination directory. What you want to copy, where you want to copy. Dot. Here dot represents a current working directory. Here dot represents a current working directory. From the current working directory of my machine, I want to copy the data to the image present working directory. That's it. Now, in order to run this Python, we need to install pip. Pip install requirements-prod.txt. So install pip software we are using to install whatever the requirements we have. Pip software install requirements-prod.txt. What is there in the requirements-prod.txt? Requirements-prod.txt file contains requirements.txt. Requirements.txt file contains what? Requirements.txt file contains what? It just contains Flask. So here, whatever the software that we need to run this Python is a Flask. So I specified that we need to download the Flask that I configured in the requirement.txt. So I mentioned a separate file. One is for normal dev environment. For a prod environment, I mentioned a separate file. So you can keep only one file also, no problem. But here I have differentiated. One is a normal txt file. Another one I have given as a prod.txt. What I mentioned in the prod.txt, again, I'm calling this txt only. Instead of that, we can give directly txt file. Which file you want to read while creating the image, that we are going to specify in our run argument. When this run will be executed, run command will be executed while creating the image. Run command will be executed while creating the image. Expose I am using. What is the meaning of expose? Python applications will be deployed to a server. Those servers will run by default on the 5000 port number. How the Java application servers are running on 8080 port number by default, Python applications are going to exposed on the 5000 port number. Python, now when I run a container for Python application, it is going to run based on 5000. Here I am giving CMD. Instead of CMD, I can give entry point also by using Python 3-am flask run based on this host I am giving. This is the command which is used to run our Python application. Run is available, CMD is available. Run is used to specify the instruction which you should execute while creating the image. CMD is used to specify the instruction which should execute while creating the container. From workdir, copy, run, expose, CMD. Python is a base image. This is my work directory. Copy the data. Copy the data from the target machine present working directory to this one. Okay. Run pip install. This install the softwares which are mentioned in this txt file. Flask I want to install. Expose 5000. I mean to say this Python application will be running in the container. Container port number will be 5000. That 5000 we can map to host port. Host port you can give as anything. CMD Python 3-am flask run. It is used to run the Python application. So this is a Docker file to run our Python application. Are you clear with this? Are you clear with this? Now, let's go to this. Containers are running na. Docker containers are running. I want to stop the container. Docker stop. Docker stop container ID. This is one container ID. I stopped it. And I want to stop another container. These are Java application containers. Good. I have stopped. Docker PS. Docker PS. Java web application. So Docker stop container ID. Docker PS. Yeah. Now currently no containers are running. Let me come out from the Java application. ls-l. Java is available. rm-r Java web app. Let me delete it. Okay. ls-l. Currently nothing is available in my present working directory. I want to clone my Python application. Take this URL. Take this URL. Git clone this URL. For Java, we need to create a war file and all. For Python, nothing is required. Git clone. I have cloned it. Okay. I have cloned it. Now go to Docker images. Java image available and Tomcat image available. Can we build Python Flask image now? For Java, we are using Maven to compile the project, to package the project. For Python, it is not required. So directly you can build the image. How to build that image? Docker build -t. Image name I am giving as Python Flask application space dot. Docker build -t Python Flask app space dot. Just Docker file, no such file or directory. Oh, guys, see what is the problem? Can you see why it is not able to build the image? Can you identify? I got the issue. What is the issue? I am executing the command from outside of the project. In this location, Python, in this location, Docker file is available or Docker file is not available? Docker file is not available. Where is the Docker file? Docker file is available inside the Python application directory. So go to Python directory, ls-l. Here we have that. See, ls-l, Docker file is available here. Python classes are available here. app.py, services.py, app.py, services.py available. Okay, requirements .txt, requirements.txt is available. Those files I am using in the Docker file. Now Docker file is available. Let me build my image. Docker build -t Python plus. Guys, for Java, we are using Maven for compiling the Java programs. .java files should be converted to .class files. War file will be created. That war file we are deploying to the Tomcat server. But by Python, nothing is required. Directly this Python program can be executed. So Docker build -t Python plus app space dot. I'm building a Docker image by using the Docker file available inside this Python Flask application. Enter. Yeah. Downloading the Python version, pulling the Python library. Python is a base image for our application now. As it is a Python Flask application, Python software is required to run this. Python software is required to run this. Yes, created. Let's go and check it. Docker images. Can you see how many new images it created now? Can you see how many new images it created? Can you see how many new images it created? 2 new images. What are those 2 new images? One is Python image, which is our base image, and a Python Flask application image also it created. Now we know the image name. Can we run this image? That means, can we create a container for the Python Flask application? Can we run the Python application by using Docker container? Can you tell me the command? You know the image name? And tell me the command. It is going to, that Python application server will run on the 5000 port number by default. That already I mentioned in the Docker file by using expose. Now, can you guys give me the command to run this Python Flask application image? First, I want the image to run this application now. I want command to run this image. Only one person responded. Tejmuddin responded. What about remaining people? Guys, come on, fast. Sachin responded, but Sachin, your command is wrong. Where is the port mapping? Docker builder. Pavan Matkar, build already. Docker build is used to create the image. Image already created, sir. Docker build is used to create the image. Image already available. I want to run the image. -t. Why -t? Where we will use -t? -t is used to specify the image name. Image already created. Why to specify -t? I just want to run the image. What is the command? Bhagirath 8080 porta. I already told. Can you see? People are Srikanta. You are saying 8080. What is the port number I told for Docker file? What is the exposed? What is the port number I mentioned as the exposed port? 5000. Then why we are using 8080? Container port already I mentioned it as 5000. That means the Python server will run on the 5000 port number. Why are you writing 8080:8080? Container port is 5000. You cannot change that. We cannot change this. In the Spring Boot application also you can specify expose 8080. That means it is going to run on the 8080 port. You can specify that, no problem. I'm giving you multiple flavors of the Docker files, guys. So I want you to realize that Docker files can be available in multiple flavors. You need to digest that. I already mentioned 5000. Bhagirath, again you are doing wrong. He is giving 5000:8080. 5000 is the host port number or 5000 is the container port number? 5000 is the host port number. 5000 is the container port number. Container port number. So 5000 should be available left side or it should be available right side. 5000 should be available left side or right side. 5000 should be available right side. Left side you can write anything. Right side port number you cannot change because Python is going to run on the 5000 port. That should be available right side. Right side colon, what you will take a colon. After colon, whatever you write, that is container port. Before colon, whatever you write, that is the host port. Subhash also done the mistake. Subhash Bodula, you are writing 5000 left side. 5000 you need to write at the right side. 5000 is the container port. Okay. Half of the people giving wrong answer. Now my Python image is created. I want to run the Python container. Python container will run on the 5000 port by default. How to run it? Docker run -d -p. This port number can be 8080 or this port number can be 9090, whatever you want. I can give this left side port number as 1234 also, no problem. But this should be 5000 only. This is container port number. I already mentioned in the Docker file as a expose. Container will be running on the 5000. Your host port can be anything. You can keep 1234, you can keep it 7070, you can keep 9090, you can keep 1122, 3344, whatever you want. Host port is your wish. Container port you cannot change. So host port I am going to configure 9090:. I need to specify container port. What is the container port? Container port is the 5000. Docker run -d -p host port container port. Host port is 9090. You can give instead of 9090, you can give 7070, you can give 8080, you can give 1111 also, no problem. You can give anything. Left side value is your wish. Which port you want to open in your host machine. Right side port you cannot change. That is 5000. That is container port. Python application will run on the 5000 port. Space Python -flask -app, my image name. Enter. Python container started. Docker container started. In that Python application is running. Okay. So on which port number it is running now? Python container application, Python application running in a container port is 5000. 5000 port I map it to host port 9090. This is my EC2 machine port number now, 9090. Go to localhost or public IP? Public IP, not localhost. Public IP :9090/tasks. Some of the REST API URL I have given as tasks. Tasks are what? Python. Yes, application is working. App works. So in this Python application app.py, so I have given default URL pattern app works. So I have given slam API/tasks. So this is the JSON data. Python application REST API is giving the data in the JSON format. So this is the URL. If you just give this one, by default, it is giving application works. So if you want to make a hit of some REST controller, API/tasks, that Python application giving some JSON data for me. Task 1, task 2, task 3, it is returning 3 records. It is returning 3 records in the form of JSON. ID1, ID2, and ID3. So Python application also deployed by using Docker. Python application deployed by using Docker. Are you clear? Are you clear? Dockerizing Python application. You can give that 5000 or host port, you can give anything, Jyoti. Python container port is 5000. Host port, you can give anything, Ra. I have given 9090 instead of 9090. If I give one more port, that also fine, no problem. Host port can be anything. Container port is a fixed value. Container port is fixed value. If I give 9091, 9091, is it valid? Yes, yes. Python Flask application running in two containers. One container running with containers, two containers are running. One container is mapped to 9090 port in the host machine. Another container mapped to 9091 port in the host machine. So two URLs are available. Two containers are available. Clear? Here I can give 9090. I can give 9091 also. No problem. Anything we can give. Anything we can give. Understand all of you? CMD, sir, this CMD is just a instruction to run the Python application. So it is a command. How jar file here, if you see in the Java Spring Boot, Java space -jar space jar. This is the syntax to run the Java program as a jar file. This is the syntax to run the Python program. So we have to remember this execution pattern. This is the syntax to run the Python application. So this is the syntax to run the Java application. That syntax we have to remember. Java application is executing as a jar file. And this is a Python application which is executing with the Python command. That is instruction we are giving to execute. All right. So with this, we are able to Dockerize Spring Boot application and a normal Java web application and Python application. So here, if you see, several images got created, Docker images, and we can see Docker containers also. So two containers are running. If you want to stop the containers, then you can go for a command called Docker space container ID. Docker container, sorry, Docker stop. Docker stop container ID. Same thing we can give Docker RM to remove that container. Similarly, Docker stop second container I have. First I'm stopping the container, then I am going to remove that container. For that RM command. RMI to remove the image, RM to remove the container. Docker PS. Now, so currently no container is running. Docker PS-A. So these all are the container status is exited. So if you want to delete all these containers, Docker system prune -a. So Docker system prune -a, it is going to remove all the stopped containers, all networks not used by at least one container, all images without at least one container associated to them, all build cache. Docker system prune -a, it is going to remove all the stopped containers. It is going to remove all the images which are not attached to any container, and all the build cache also it is going to remove. Just give Docker system prune -a to remove the stopped containers and to remove images which are not associated to any container. Just give yes. Yes. Now deleted all the containers. So see here, when the containers are deleted, it released 1.4 GB of space. So that cache files, everything it deleted. Now Docker PS-a, nothing is available. I have pruned them. Docker system prune -a, it is used to delete all the unused containers. Okay. So now to display all the running containers, we can go for Docker PS. Docker PS to display all containers, all running containers. All running containers, we are going to use a command called Docker PS. Okay. Now, how to display all containers? To display all containers, we will use a command called Docker PS-A. All the containers it is going to display. How to stop a particular container which is already running? Stop the container. Stop the container. In order to stop the container, we will use Docker stop container ID. How to remove the container? How to remove the container? Delete the container. In order to delete the container, we have Docker rm container ID. To remove the container, we are using Docker rm container ID. So these are the commands. How to remove? Remove unused. To remove stopped containers and unused images. What is the command I have executed for that? Docker system prune -a. Docker system prune -a command I have executed. It is going to remove all stopped containers and unused images. If the image is not attached to any container, then that image also will be pruned. Prune means delete them. Got it? See these container commands. To display all the running containers. Docker PS to display all the running containers. PS-A all the containers. Stop particular container. The container is running. I want to stop that particular container. So we are going for Docker stop container with ID. Remove the container. My container is available. I want to remove that container from this machine. Docker rm container ID. RMI to delete the image. RM to delete the container with container ID. How to delete? Stop all the not running containers and unused images from this Docker system prune -a, which is going to remove all the stopped containers and unused images. All right. Yes. Next one. Next to 3 topics. Very important. Damn sure questions in the interview. Docker volumes, Docker compose, Docker swarm. Let's talk about Docker volumes. When I'm explaining Docker file keywords, there is one keyword called volume. When I'm explaining Docker file keywords, I explained about one keyword called, just I gave the introduction for volume. What I mentioned as what is the purpose of the volume keyword in the Docker file? What is the purpose of a volume keyword in the Docker file? Storage purpose. Okay, it is used for storage purpose. Fine. Next, Docker volumes. So before going to understand this Docker volumes, how to work with Docker volumes, let me give you a scenario. What is this Docker volume? Guys, I am running my application in one container. I'm running my application in one container. This is container 1. I'm running my application inside one container. It is container 1. As part of this container, one database is created. As part of this container, one database is created, or some files are created. As part of this container execution, some data got generated and that data got stored into the database. So this application is executing inside a container. Container is available. Inside that container, my application is executing. My application is storing the data to MySQL. So whatever the database we created in the container, that is local database. That database is available only for that container. Whenever you stop this container or whenever you delete this container, that data will not be available. So my application is executing in a container. In that container, database is started. My application storing the data to that database. Okay, application executed. Data is also stored in the database. Now I have deleted my container. When I delete that container, can I access that database data? Is the database will be available, or a database also will die along with the container? Database will be available, or a database will not be available? Database will not be available, because where the database is created? Within the container, right? Where the database is created? Database created within the container. If a container is deleted, the database will be data will be available, or data will not be available? Data will not be available. So whatever the files you create in the container, whatever the data you store in the container, if the container is executing, that data will be available. If a container is stopped, or if container is deleted, then you cannot get the data. That data will be deleted along with the container. Are you guys able to understand? Now here, what is my requirement is I want to start the containers multiple. I want to share the data. I want to share the data from one container to another container. Now, for example, let me take one example. Here, I am creating one container. Container one. I'm taking. One second. I'm taking container one. Here, in this container, I am running Nginx server. Nginx is a web server. Nginx is a web server I'm running. To host a static website, I'm taking Nginx. So this is my container one. It is running in the Docker, right? In this Nginx one is going to access one file which is called as index.html. It is going to access one file called index.html. Are you guys getting my point? Container is available, that is going to access index.html. Same file I want to refer from another container also. Whatever the file we have, I want to persist data changes. Whatever the changes we are doing for that file, that changes should be available for two containers. It should not be for one container. I want to exchange the data. I want to persist the data which is generated by one container. Whatever the changes I made for index.html, that change should be available for this one as well as for this one also. So basically, container data will be specific to only that particular container. Whatever the files you create in the Docker container, whatever the data you generate in the Docker container, that data will be available unless that container is available. If a container is deleted, then that data will not be available. So container means one kind of virtual machine, right? Which is going to execute. So now, if you want to share the data from one Docker container to another Docker container, if you want to persist the data which is generated by the Docker container, we need to go for Docker volume concept. We need to go for Docker volume concept. And in detail, if you want me to explain here, guys, this is my machine. This is my machine. It is my EC2 machine. Let me take this. Now, Assume that this is my AWS cloud. Assume that this is my AWS cloud. In this AWS cloud, I am installing Docker. In this AWS cloud, I'm taking one EC2 machine. This is my EC2 VM. EC2 virtual machine I'm taking in the AWS cloud. In this EC2 virtual machine, I installed Docker. And in this Docker, one container is created. In this Docker, one container is created. So this container is generating some data. Assume that some data is generated by the container or some file is created inside the container. File is available. Now, if a container is running, this file will be available. So I have taken AWS cloud. In the AWS cloud, I have taken one EC2 machine. In the EC2 machine, I have installed Docker and I have started Docker container. That Docker container generated some data. If I delete that Docker container, can I access that data? If I delete my Docker container, can I access that file data? Will that file be available if I delete my Docker container? Come on, guys. Docker container started. The Docker container created a file. In that file, it stored some data. If the Docker container is deleted, file will be available or file will not be available? File will not be available. Now, here, I want to store the data permanently. Even if container is deleted also, I want to have that data. For that purpose, we will go for Docker volumes. Docker containers will generate some data. It can be a file or it can be a database or it can be some logs, whatever it is. It can be a file data. It can be a database data. It can be a log file, whatever it is. When the container is executing, some data will be generated. If a container is stopped, that data will not be available, that data will be deleted. So for that reason, we are going to use Docker volumes concept. What is a Docker volume? Basically, Docker volume is used to map our host machine with a container. Host machine with a container. I am going to create one file in my host machine. I'm going to create one file in the host machine. I'm going to mount container files to host machine directory. That means even if that container got deleted, that data will be available in the host machine. For that purpose, we are going to use Docker volumes concept. So basically, it is kind of taking the data from the container, storing in the host machine. So if I take the data from the container, if I store to the host machine, even if the container got deleted, our data will be available. So data persistence, permanent data storage we can do by using Docker volume concept. Are you able to understand what is the Docker volume and why we need to go for Docker volume? All of you able to understand what is the Docker volume and why we need to go for Docker volume? Can anyone tell me what is the purpose of Docker volume? Can anyone tell me what is the purpose of Docker volume? Come on, guys. Quick. What is the purpose of Docker volume? What is the purpose of Docker volume? People are not responding. What is the purpose of Docker volume? Storing the container generated data in the host machine. basically. Container is executing, container may generate the data in the database, or container may create some files, container may generate some data. So whatever the data that is generated by the container will be deleted if you delete the container. So data is creating in a container. If you delete the container, the data also will be deleted. I don't want to delete such kind of data. Whatever the data generated by the container, I want to store in the host machine, so that if a container is deleted, no problem, data will be available permanently. For that purpose, we are going to use Docker volumes. Docker volumes are preferred mechanism for persisting the data generated by Docker containers. Docker volumes are used to persist the data generated by Docker containers. Are you clear with my point? What is the purpose of going for Docker volumes? Docker volumes are used to persist the data generated by Docker containers. What is the main use of the Docker volume? So what is the main use of Docker volume? Right. So Docker volumes we can use to decouple the data storage from the Docker containers. Using Docker volumes, we can decouple data storage from Docker container. Storage from Docker container. If we store the data in the Docker container, if it is deleted, then it is going to delete the data also. Using Docker volume, we can share the data among multiple containers. For example, my application running in 2 containers, my application want to use the same database. So the data which is storing in the database should be shared between the 2 containers. Using Docker volume concept, we can share the data among multiple containers. Among the multiple containers. Are you guys clear with my point? Are you guys clear with my point? Okay. We are going to attach the Docker volume to the container for storage. So when the data is stored to the volume, if the container is deleted also, the data will be available in the Docker volume. If Docker container is deleted, volume will not be deleted. On deletion of container, Docker volume will not be deleted. On deletion of container, Docker volume will not be deleted. Clear with my point? So if you are confused with this, let's see here what is Docker volume. Docker volumes are the file systems mounted on the Docker containers to preserve the data generated by the running container. The volumes are stored on the host independent of the container lifecycle. This allows users to back up data and share file systems between containers easily. So that means whatever the data which is generated by the container, we are going to store into host machine. If the container is deleted, our data will be backed up in the host machine. When the data is backed up in the host machine, multiple containers can share that data. We can share the data with multiple containers by using Docker volumes. So Docker volumes are used to generated by Docker containers. Using Docker volume, we can decouple data storage from a Docker container. Using Docker volume, we can share the data among multiple Docker containers. On deletion of container, Docker volume will not be deleted. Are you guys getting my point? What is Docker volume? Data means database. You can take an example database. We are running our application with MySQL database. If you delete your container, database also will be deleted. We are packaging our application softwares, right? We are packaging our application, Java code and MySQL database. Database also running in the container. If you delete your container, database also will be deleted. I don't want to do that. Same thing with files also. Any log file, for example, log file is created. My application is running, log file is created. If I delete my application, log file also will be deleted. Understood, guys? So to simply say that volumes, Docker volumes are acting as a plug between the host machine and the Docker container. So I want to connect a pipe between the container. I want to connect a pipe between the container and the host machine. So to transfer the data to the host machine, which is generated by the Docker value. Now here container is available. Container is generating the data. I want to store the data to the host machine. So to generate whatever the data generated by the container, I want to take the backup of that data. Why? Because tomorrow if the container is deleted, I need to maintain the data backup. For that purpose, we are going for Docker volume. Docker volumes are the file systems mounted on the Docker containers to preserve the data generated by the running container. So that means we are going to create one file in the host machine. We are going to mount our file to Docker container. So whatever the data generated by the container will be stored to our host machine. So if you delete the container also, no problem. Data is already mounted to the host machine. When the data is mounted to host machine, multiple containers are running. Multiple containers can use the same data. We can share the data among multiple containers. Are you guys able to understand? Docker volume. Docker volume. Yes, Docker container and a Docker volume. You see this? Docker container is running. I don't, whatever the database is created in the Docker container, if I delete that container, database also will be deleted. I don't want to delete the database. I want to back up that data. I want to maintain the data in the host machine. For that, we are going to create a volume and we are going to mount it. Guys, theoretically, practically, I will show you now. Theoretically, are you clear? Theoretically, are you clear with the Docker volumes concept? What is the purpose of Docker volumes? What is the purpose of Docker volume? Come on, fast. Guys, I need your response. What is the purpose of Docker volume? Docker volumes are used to persist Docker container data in the host machine. Docker volumes are used to persist the data generated by the Docker containers in the host machine. Why we need to store container data in the host machine? What is the reason? Why we need to store container data in the host machine? What is the reason for that? Yes, if you don't store it, if you remove the container, you will lose your data. For example, my application database are running in the container. If I want to share the data to multiple containers, then simple example, guys. Let's go for microservices based application. Let's go for microservices based application. Here, products API is running. Product API container is running. Product API container is running. Here, tracking API is running. Tracking API container is running. So whatever the products you purchased, that will be available in the database. And a tracking API should have the access for the database. Tracking API should not have the access for the database. Both APIs will use a different database. Both APIs should use the same database. Database should be same, or a DB should be different. Now how to share the DB to two containers? Are you going to use a separate database for the product API in the container? Are you going to use separate database for tracking API in the container to different databases or single database? Are you going to use a different databases for the two APIs, product API, tracking API in the e-commerce application, or we need to use a single shared database for two APIs now? Single API. How can we share the database for two containers? Volume. We are going to use Docker volume. Volume is used to share the data among multiple containers. You got my point now? It's taking time for the people to understand theory. Docker volumes. To be simple, volume is used to store the data of the Docker container in the host machine. Whatever the data generated by the Docker container, I want to store it. Chalo, let's see Docker volume commands. So how to work with the Docker volume? So Docker volume command, how to create the volume, how to mount the volume to the container practically, how to share the data. Let me demonstrate on this. It is to be simple. I can say somebody gave the answer. EBS additional volume in the AWS. Yeah, that is perfect, man. That correct comparison. In the EC2, root volume is available. When I delete the EC2 instance, root volume will be deleted. Additional volume will not be deleted. So in the Docker, volume is like that. It is an additional volume, additional storage. If you delete the container also, the data will not be deleted if you go for volume concept. Volume is like a hard disk to externalize the data storage. Go for Docker volume commands. So here, Docker volume, you can check it by using Docker volume commands. You can go for Docker volume --help. Let me execute these commands one after other. Yeah, I'm coming out from this Python ls-l. Let me remove Python Flask application. Clear. ls-l. Currently, I don't have anything here, guys. I don't have any images and I don't have any containers. Currently, my system is clean and green, empty. Now, Docker volume help. It is used to see the commands of the Docker. See here, Docker volume commands I can see by using Docker volume help. Create command, which is used to create the Docker volume, Inspect, it is used to see the information of the volume. ls, to list down the volumes. Prune, remove unused volumes. rm, remove one or more volumes. Okay, so now if I go for Docker volume ls, there is one local volume is available. Now Docker volume prune, it is used to delete all the volumes. Okay, Docker volume ls, currently there are no volumes available, right? So here we have some commands for the volumes. Docker volume help command to display list of volume commands, to display Docker volume commands. Docker volume help to create a volume, create Docker volume. How we are going to create Docker volume? To create it, Docker volume, we can give volume name. So what is the name you want to give for that volume? You can use it, right? display Docker volumes, display Docker volumes. In order to display the volumes, we can go for Docker volume ls. Okay. Now, if you want to inspect the volume, when that volume got created, if you want to see, inspect the volume. If you want to inspect the volume, we have a command, Docker volume inspect volume name. Whatever the name you give for that volume, you can inspect it. Inspect that Docker volume. Okay. Next one. Let me go for volume remove. How can we remove the volumes of the Docker? Remove Docker volume. Right. What is the command? RM command is available. Docker volume RM volume name. Which volume you want to remove? If you want to remove all the volumes which are not using, prune command. Remove. Here they have given Docker volume help. Prune. Remove all unused local volumes. Right? Remove unused volumes. Remove unused volumes. So I'm going to specify Docker volume prune. All the unused Docker volumes will be removed. So these are the Docker volume commands that we need to remember. Guys, are you clear with this one? Volume help, it is going to display the list of Docker volume commands. To create a particular volume, Docker volume name. Whatever the volume we create, we will associate that volume to Docker container for storage. I will show you that. Display Docker volumes, Docker volume ls. What are the volumes created? We can display them. To inspect a particular volume, we can go for Docker volume inspect that particular volume name which you created here. That name we need to specify. If you want to remove that Docker volume, then I will go for Docker volume RM. That is volume name we have to specify. If I want to remove all unused Docker volumes, so then you can go for Docker volume prune. It is going to remove all the unused Docker volumes from our Docker. All right, let's do some exercise with the Docker volume. Let's do some exercise with the Docker volumes. Guys, what is the exercise I'm going to do is, let's observe carefully. What is the exercise I'm going to do is, I'm going to create one Docker container. I'm going to create one Docker container. This is my container. This is my container. In this container, I'm going to create one file called index.html for web page. Then I'm going to mount this file to my host machine. Host file. Index.html file. I'm going to host file. Now I'm going to create another container and I want to share this file to my another container. Now I'm going to point this file to another container. So first I will go for one container. In that container, I will create one file. I will make some changes to that file. Then I will remove this container. I will remove this container and I will try to access the data, whatever the data which is generated by the first container, the same data I will try to access from the second container. So both containers will be available in my host machine. So first container is using some file to generate the data. That data I am going to mount to the host file. After that, I will delete that container. Then the data will come to second container. From that file, I am going to take the data to the second container. I will show you how the data can be shared among multiple containers. Are you guys clear with this scenario? Okay. For this process, I'm going to do some commands, guys. Observe carefully. I will provide the notes also for that. You don't worry about the commands which I'm going to execute now. So a lot of commands I'm going to execute in order to demonstrate on the Docker volumes. Okay. Now, first, I'm going to pull one image called Nginx. What is the image I'm going to pull? Nginx. How we have HTTPD web server to run the static websites. Similarly, we have Nginx as a web server. It is also used to run the static web pages. Docker pull Nginx. So it is a predefined official image in the Docker. Nginx, a web package image. I am taking that. Pull it. I pulled Nginx image, which is a web server to run the web application. Yes, that image I pulled. All right. When we pull that image, can we check it? Is that image available? Is that image available now? Are we able to get the Nginx? Are we able to get the Nginx? Yes. So this is the first command I have executed. Docker pull Nginx. All right. With this image, can we run a container? With this image, can we run a container? Yes or no? So can you tell me the syntax to run a container? Can you tell me the syntax to run the container? Docker run. I'm giving the name for the container. I'm giving the name as a web application. Web application -d -p 80:80. Web server running on the port number 80. HTTPD will run on the 80. That 80 container port. This 80 is the container port. Container port I am mapping to host port 8080. What is the image name? Nginx. So what is going to happen with this? Nginx server is going to start by using this Docker container. Docker run. For the container, I'm giving a name -d detached mode -p port mapping. Nginx is a web server which will run on the port number 80. I am mapping that 80 to my host machine 80 port number. Nginx is the image name. Nginx is the image name. Now enter. Docker container started. Let's go to our EC2 instance. Take a public IP. Just hit this. Let's hit this. Are you able to see static website by using Nginx? If you see this web page, Nginx web server is successfully installed and working. Further configuration is required. For online documentation support release, go to this website. Thank you for using Nginx. Am I able to set up? Am I able to set up a static website by using Nginx with Docker container? Yes, this is the command I have executed. First, I pulled that image. Then I have executed that image by using Docker container. For that container, I have given the name as a web app. Web app is my container. Are you clear? Are you clear? Guys, come on. So here by default, a static web page is displayed. Welcome to Nginx. I want to change the content of this. I want to change the content of this. So this static website file is available in the host machine, or it is available in the container now. Nginx server is running in the host machine. Nginx is running in the container machine now. Nginx is running in the host machine. Nginx is running in the container now. This Nginx is running in the container. Inside the container, index.html file is available. So where is this index.html now? Index.html is available where? Inside the container. Okay, can I change that file which is available inside the container? Can I change that file inside the container? Yes, we can change it. By default, it is giving a default page. Now, I want to change that file which is available inside the container. For this, I need to go inside the container, guys. For that, I need to go inside the container. How can I go inside the container? By executing bash command. Docker exe -it. My container name is a web app bash. I want to execute a bash script inside the container. Container is also a machine. Container is also a machine. I want to execute the bash script inside that container. Docker exec -it interactive mode web app is the name of the container. Bash run this. Now what is this? Currently, earlier I was having a EC2 user my IP, but currently it changed it to what? Now my terminal is pointing to host machine. My terminal is pointing to container machine. My terminal is pointing to host machine, or it is a container machine now. It is pointing to container machine. It is pointing to container machine. Why I am going to container? The index.html is available inside the container. Let me change that. So let me go to /user/share nginx location html ls-l. Can you see index.html here? Can you see index.html here? Yes or no? So this location is a container location, or this location is the host machine location? Container location or host machine location? Container location. Let me add the data to that file. Echo welcome to Ashok IT. I'm changing that website default page. Where I want to write that data? Index.html. Done. Cat index.html. Is it changed to welcome to Ashok IT? Yes. Refresh. Perfect. Am I able to change the file in the container? Am I able to change the file in the container, guys? Index.html. Come on. Am I able to change the file in the container or not? This is the command I have executed. Then after I have been to that location where the container is available. This is the location where the index.html is available. Then I have executed the echo command to change the file. I have executed to change the file. Good. So total 5 commands I have executed. First command is used to pull the Nginx image. Nginx is a web package, web server. I executed this web server by using Docker container. I have given a name for that web app. Now inside this container, I want to change the index.html file. So that's why I have selected web app with bash. So I have executed this command. This is used to change the directory. I'm going to the location where the index.html available. Then I have added this content to index.html. Now when I access that machine, it is giving welcome to Ashok IT. It is giving welcome to Ashok IT. Okay, it is fine. It is working. It is working. Where I have changed that file now? In the container 1, index.html. Let me do one thing. Let me exit from here. I am in the container machine. I'm exiting. When I do the exit, then what happened? I came to my EC2 user, that is a host machine. In the host machine, Docker PS container is running. Let me stop the container. Docker stop container. Docker stop the container. I have stopped it. I have stopped my container. Come on, guys. I have not deleted. I just stopped my container. Then again, start the container. Start the container. Container started. I have stopped it and I have started. Now, see here, the data is available. If I stop it and if I start it, data is available. Are you guys able to understand? If I stop it and if I start it, the data is available in the container. Come on, data is available. Data is available. Now, if I want to run this Nginx in another container. I want to run the Nginx in another container, web app 2. I'm running this Nginx in another container called web app 2. Port number 80 is already using. Okay, let me stop it. Docker, stop the previous container. I stopped it. I'm running another container called web app 2. Web app 2. The container is already in use. Okay, let me give web app 3. Web app 3. I have started that container web app 3. Now refresh. Then what happened? The file is back to normal state or not? The file is back to normal state or not? So whatever the change I have made in the container 1, is it reflecting to the container 2? Whatever the change I made in the container 1, is it reflecting to the container 2 or it is not reflecting to the container 2? It is not reflecting. It is not reflecting. If I delete that first container, I lost the change whatever I made. Whatever the index.html file I have changed, that is specific to only first container. If I delete that container, I will lose the data. Can I exchange the data in other container? I cannot. So permanent storage available for the container data, permanent storage not available for container data. Permanent storage available for the container data, permanent storage not available for the container data. Permanent storage not available for the container data. Are you guys clear with my point? What is the problem we are facing? Are you guys clear with my point? What is the problem we are facing? I have stopped this first container, whatever is executed. I have stopped this container. Stop the Docker stop container ID. Docker stop that container ID. Now I am running another container with a name called web app 2. So the file which I have changed in the first container will not be available for the second container. So to overcome this problem, we are going for volumes concept. I have started one container. I have modified index.html. This is the location of that index.html in the container. I have modified. I have stopped that first container. Then I'm starting another container for the same image. Nginx here I have started. Nginx image I used and I started a container called web app. Let me give it as a web app 1. Web app 1 here I will give it as a web app 1. Web app 1 container I have started. I have stopped it. Then I have started another container called web app 2. The file which I have generated, which I have changed in the web app 1 container, it is not available for the web app 2. It is giving default file. It is giving default file. So we are not able to use one container file in the another container. So to overcome this problem, we are going to use volumes so that we can share the data among the containers. Now, how I am going to use this concept? How I am going to use this concept? Okay. How to share the data from one container to another container. Are you guys able to understand my point? Are you guys able to understand my point? I want to use volumes concept. I want to use volumes concept. By using volumes, I want to share the data. How we are going to share the data? First, I'm going to create one volume. First, I'm going to create one volume. First, currently Docker PS, one container is running. One container is running. Let me stop that also. Docker stop container. That container also stopped. ls-l. Currently, I am working in this directory. Clear this Docker PS. Now, Docker volume ls. Currently, there is no volume available. Let me create my volume. Docker volume. Docker volume. I'm creating volume with a name called new underscore val. New underscore val I'm giving, which is used to create my value. Okay. New underscore docker volume create, sorry, docker volume create new underscore volume. New volume got created, docker volume ls. Now can you see new volume got created? Can you see the new volume got created? Yes, new volume got created. Now I want to see the images, docker images. Nginx image is available. Now I want to run this Nginx image by using docker container. For the docker container, I want to attach one docker volume. I want to attach a docker volume to the docker container. How we are going to do that? Let's observe. Docker run -d --name. I'm going to give this name as a web app 20. Some name I am giving -mount. I want to do the mount. Where I want to do the mount? Source is equal to new underscore value, comma, destination is equal to where that HTML file will be created, /user /share nginx html -p space 80:80 space nginx. This is the command which is used to mount this. Whatever the data is available in this HTML file, HTML directory in the Docker container, I want to mount it to new volume. By using mount, I'm giving source is equal to new volume, destination is equal to this location. So whatever the data is generated in this directory in the Docker container, that is mounted to this volume. New val is the name of my volume. New val is the name of my volume. So this is called mounting Docker container to Docker volume. Are you guys clear? Docker run -d name I am giving for the container as a web app 20, and I am mounting that container location to my volume. That means whatever the data is generated in that location, that will be mounted to my volume. Good. Run it. Docker container started. Docker container started. Refresh. Yes, web application is running. Can we change the content of this file now? Can we change the content of index.html? Where that file can be changed? We should go to this container. What is the name of the container? Web app 20. Go to that. In that, go to this location. Go to this location, HTML. In that, change that file, index.html. Changed it. Okay. Refresh. File is modified. File is modified or not? Index.html file modified or not? Index.html file modified. Now let me come out, exit. I came to my EC2 user. I came to my EC2 user, ls-l. Can I stop that container now? Whatever the 20 container is running, I want to stop it. Docker stop container. I have stopped. Now see Docker PS, no container is available. Now let me run another container with 21. Let me go here. Let me run with 20. Let me run with 20. Guys, now I'm running with 21. Container 20 stopped. I'm running with 21. I have started. Now when I run this 21, file is not changed or file is not changed. Index.html, file is changed or file is not changed. File is not changed. So are we able to use the same file for two containers? Are we able to use the same file for two containers? Index.html. Yes, we are able to use it for two containers. That file is stored in the Docker value. First, I have created a container with a name called webapp20. Webapp20. In this container, I have opened index.html. I modified the content. Then I have stopped this container. Then I have started another container, webapp21. Okay, whatever the data I stored in the index.html, which is available in the webapp20 container, same index.html content I am able to access in the webapp21 container. How come it is possible? How it is possible? How it is possible? How I am able to share the data from 20th container to 21st container? By mounting volume in the Docker. Okay. So with this, practically, are you able to understand this? Practically, are you able to understand this? So if you execute these commands, then you will understand. It is used to pull the Docker container, then run that container, give the name as a webapp1, then go to that container, go to this location, change that file. Then after, stop that container. Then after, stop this container. Then run another container. Then whatever the changes you have done, you will lose your changes. Here, first container will give you this output. Second container will give you default output. Why? There is no sharing. There is no volume. Now here, we need to use volume concept. So what we need to do here? Docker volume create new underscore volume. Docker volume create new underscore volume. Now after Docker second container started, stop that also. Docker stop container ID. This is for testing purpose. Data is sharing or data is not sharing. Here you are seeing the problem. You are running one container, you are modifying the data, you are stopping the container, you are running the another container, data will not be available. So you will stop the second container also. Then create the volume. By using this volume, then start your first container. Okay. So this is the command we are going to use to run the container by using volume. I am giving container name as 20. Then I am giving mount source. This is the name of the volume and this is the destination. Whatever the data generated in this location, that should be mounted to this volume. Okay. Once it is done, Docker stop volume. Sorry, Docker stop container ID. Container ID. So before stopping that container ID, let's execute these things. Go to webapp20, change the file data, then stop the container, then start the another container. With this 21, we are going to start it. So in the sequence, if you execute these commands, then the Docker volumes lab task will be completed. In the order only you have to execute. So let me give some comments to understand it in more better way. Here I am doing pulling Nginx image. Pulling Nginx image from Docker Hub. It is an official image, guys. Running the Nginx image using Docker container. Running Nginx image using Docker container. Okay, mapping to 80 port only. Now these commands modifying here, once you have run this, access static website using EC2 VM. EC2 VM public IP. First step, you are pulling the image, you are running the image. Then access that website by using public IP of your EC2. Yes, website will be displayed. Now, so here note, here access a static website using above static website using EC2 VM public IP, which is hosted by Nginx. These steps are used to host a static website. Modify the content of the static website in the container. Modify static website content in index.html file. File is created, file is available in container. File is available in container. So we are going to that container location. Container name is a web app 1. Going to that container with the bash command, navigating to the location, changing the file. Now here also access static website using EC2 VM public IP, which is hosted by using Nginx. Modified content should display. Modified content should display here. Here default content will be displayed. Here we have made the change that modified content should be displayed here. Then stop the Docker container. Stop the container. Stop Docker container. Stop Docker container. Start another Docker container. Start another container with the name as web app 2. Web app 2. Stop the Docker container, which is web app 1. Right here I'm starting the running the Nginx image as a Docker container with the container name as web app 1. Here the container name is a web app 1. Here the container name is web app 2. Are you guys clear with my point? Stop the Docker container, which is web app 1. Start another Docker container with name as web app 2. Then run this. Now here also access static website. Checking multiple checks we are doing. Multiple checks we are doing to demonstrate on the values. Here first time I have started a container. I have modified the content. Then I have accessed that modified content. Okay, fine, very good. I am stopping that. Then I am running a second container to see whatever the data I have modified, is it reflecting here or not? Definitely it will not reflect, because the file which we have changed is specific to first container. It will not be available for the second container. So that's why I'm stopping the second container also. Access the static website using EC2 VM public IP, which is hosted by Nginx. Okay, modified content will not be displayed. Second container, stop the container. Okay, stop the Docker container, which is web app 2, because there is no use, we are not able to share the data. Then after, create the Docker volume. Create a Docker volume with the name as a volume 1. Start the Docker container. Start Docker container by mounting Docker volume. Yes, this is the place where we are running a container by mounting Docker volume. After this, volume mounted. After this mounted, access a static website using public IP, which is hosted by Nginx. Then after that, modifying the content. Here, after modification, access this. Stop the Docker container. Stop the Docker container. Now run another Docker container. Run another Docker container. Data, modified data should reflect here also. Modified data should reflect here also. So this is the lab exercise. Lot of things we have done to demonstrate on Docker volumes. Finally, I proved that we can share the data from one container to another container by using Docker volumes. Guys, is it proved that data is shared from one volume to another volume? Am I able to share the data from one volume to another volume? First, I started a container 20. In this container, I have modified index.html. I stopped it. Then I have started another container. Whatever the file I modified in the first container, my second container also able to access the same file. The reason, first container mounted to one Docker volume, second container using the same Docker volume. So whatever the data which is generated into that location of the first container, same data is available for the second container also by using Docker volume. So here we are able to share the data among the containers by using Docker volumes. It is a additional storage. It is a backup of the container data. It is the backup of the container data. Here I have given mounted location, source and destination. Source and destination I have given here. Complete data if you want, then you need to give your root directory. Then complete data will come. Here I have given only this location, right? Only this data will come to this value. If you give root location, then complete data will come to the value. Can you guys practice this volume concept? Can you guys practice Docker volumes concept? Are you clear with the volume? Volume name can be anything. That's your wish. Docker volumes. Volumes are used to persist the data generated by Docker containers. Using Docker volume, we can be decouple data storage from the container. Using Docker volume, we can share the data among multiple Docker containers. On deletion of the container, Docker volume will not be deleted. That is already proven. So some of the commands related to Docker volumes. Here I have demonstrated that by using Nginx package. Pulling the image, running the container, modifying the content, stopping the container, starting another container, start the another one. Changes will not display here. Changes we made in first container will not reflect here. Changes we made in the first container will not reflect here. That is the problem. So that's why I'm stopping that. Then I'm going to, here is we identified a problem. Whatever the change I made into the first container, that is not going to reflect in the second container. That is the problem. To overcome that problem, I'm creating a volume here. I'm stopping that container. I'm creating the volume. I am attaching to the container. This is called mounting. I am mounting my volume to the container. This data will be stored to the volume. Then same volume I am mounting to another container. Same volume I am mounting to another container. So that whatever the data we change it to the first container, that data will be available in the second container also. Because they are using same value. 20 container, 21 container, both are using the same value. Data is sharing. All right. New volume. You can give any name. Clear, guys? Yes. Instead of giving the volume name, you can give the path of your EC2 also. That is called hosted volume, right? Here I'm given the source as a volume name. Basically, we can use the volumes in three ways. One is named volume, another one is anonymous volume, third one is hosted volume. Hosted volume means we are going to specify the path of the host machine where that where that container data should be stored in the hosted machine, we can specify that directory location. That is a hosted value. So this is a named value. I have created a name. That is a Docker value. It is in the Docker software, right? So there are 3 ways to work with the values. So tomorrow I will specify the location in the host machine, the location in the host machine, right? Yeah. So please work on this assignment, work on this lab exercise. So you will understand how the data is getting shared. So tomorrow I'm going to tell you how to work with multiple types of values. What is the named value? What is anonymous value? What is the host machine value? That we are going to discuss in the tomorrow session. If I explain more than this, you will get overloaded, guys. So a lot of commands I have executed here. Okay, good. So tomorrow I will give that differentiation between the hosted value, named value, and anonymous value. Then after we'll talk about Docker Compose in the tomorrow session. Thank you. With this, I'm stopping for today. I will upload these notes. So please practice it before coming to tomorrow session. I will upload right now. So please practice it. If you don't practice this volume concept, you can't understand, guys. Theoretically, you can understand it is used to store the container data in the host machine, but practically it is little challenging to implement. So you need to be very careful. Thank you, guys. We'll see you in tomorrow session. Bye bye. Yes, Srikanth, I will upload it now.